Good morning. This video is about how to find a linear function from an equation, but first let's review how to find it from a table. To find it from a table, the really important piece is that the rate of change between 2 points needs to be constant. So if we look at example 1 as our table, we have our x values on the left and our y values on the right. We have the points under x are 2, 4, 6, and 8, and under y are -1, 2, 5, and 8. So the important piece here is that our rate of change is equal to our change in y over our change in x. That's how we find our rate of change. So what we need to do is we need to start. We could do it either from our x values first or from our y values. I'm going to do our x values and then our y values. So the first value I have are 2 for x and -1 for y, and then my second set is 4 for x and 2 for y. I have to find the change between them. So I'm looking at my x values of 2 and 4, and I'm saying, okay, to get from 2 to 4, what am I doing? I am adding 2. And then I'm looking at my y's. From -1 to 2, what am I doing? I'm adding 3. And now I'm going to put that into a ratio, which is my slope, my rate of change of my change in y, which was 3, over my change in x, which was 2. So the idea behind if a table is a function is that it has to be constant. So all of my rate of changes have to equal 3 over 2. So let's look at the next set of points. For my x, I'm going from 4 to 6, I'm adding 2. And on my y's, I'm going from 2 to 5, I'm adding 3. My rate of change is still 3 over 2. Okay, and then my last point, I'm going from 6 to 8 for my x's, goes up by 2. And then for my y's, I'm going from 5 to 8, which is 3. My rate of change is the same. So I know that this is a linear function because my rate of change is constant. It's the same. Let's look at this next table. This next table has the points 1, 1, 3, 9, 5, and 25, and 7, and 49. So my coordinate points, my x is 1 and my y is 1, my x is 3 and my y is 9, my x is 5 and my y is 25, and my x is 7 and my y is 49. Now if I look at this table, I definitely see a pattern. I know that the x's are squared. So if I take 1 times 1, I get 1. 3 times 3, I get 9. So there's definitely a pattern there. But that doesn't mean that it's going to be a linear function. It doesn't mean that it's going to be a straight line. So how do we find out if it's a straight line? We need to find our rate of change. So again, we're going to look at the changes between our y over the changes between our x's. So if I look at my y's, I'm going from 1 to 9. That means I'm adding 8. And then my change in x is I'm going from 1 to 3. I'm adding 2. So my rate of change is the change in y over the change in x. I have 8 over 2. That reduces down to 4. So between those 2 points, my rate of change is 4. So let's see if that's the same slope as my other ones. My next 2 points, for my y, I'm going from 9 to 25. I'm adding 16 there. And then from 3 to 5, I'm adding 2. So my ratio is my y's, change of y's, which is 16, over my change in x's, which is 2. 16 divided by 2, that gives me 8. So my rate of change between my first 2 points was 4. My rate of change between my next 2 points was 8. They do not equal each other. So this is not a linear function. This is going to be a non-linear function. Okay, let's go ahead and start with equations. So I am skipping all the way to my first equation. So our success criteria is I can determine if a function is linear from an equation. How do I do that? I need to be able to identify my exponents on my x variable. So the big idea between finding a linear function from an equation is looking at what the x variable is raised to. For it to be a linear function, it has to be raised to the 0 power or to the first power. So for example, x to the 0 power, or x to the first power, or just x by itself. Now, let's look at example 1. Example 1, the equation is y equals 3x plus 5. If you compare that to example 2 is y is equal to 3x squared plus 5. The big difference between those two equations is the exponent attached to the variable. So example 1 was y equals 3x plus 5. That one is going to be a linear function because it's raised to what exponent? So it's a linear function because the x variable is raised to the power of 1. Now you may say, what do you mean 1? I don't see an exponent attached to the x. Remember, a number raised to the power of 1, so for example 5 raised to the power of 1, is equal to that number. There's only one 5. 5 raised to the power of 1 is equal to 5. Same idea with x. X by itself, what's the invisible exponent? Well, the invisible exponent is x to the power of 1. So, according to my definition, to be a linear function, my x has to be raised to the power of 1 or 0. It is raised to the power of 1, so it's a linear function. Now, if we look at example 2, example 2 says y equals 3x squared plus 5. Because the x variable is raised to the power of 2, it's a non-linear function. It means it's not going to be a straight line because it's raised to the second power and not the first or the 0. Let's try 2 more examples. In example 3, I have y equals x over 3 minus 2. In example 4, I have y equals 3 over x minus 2. The big difference between those two equations is where the variable is, our x variable is. In example 3, it's in the numerator. In example 4, it's in the denominator. So, if we look at example 3 first, we have y equals x over 3 minus 2. I could write this same exact question as y equals 1/3 x minus 2. I could take that 1/3 out and put it right next to the x, because 1/3 times x is equal to x over 3. So now that I have x outside of a fraction, so y equals 1/3 x minus 2, I can look at my x and I can say, oh, well, that's raised to the power of 1. So that's going to be a linear function because it's raised to the power of 1. Let's look at example 4. Example 4 has the x in the denominator, and that's a big hint. Whenever the x is in the denominator, it's going to be a nonlinear function. Why is that? If we think about the definition of it has to be raised to the power of 1 or 0, if it's in the denominator, it means that it's going to be raised to a negative exponent. So denominator in the denominator means it's going to be a negative exponent. So if you ever see it in the denominator, it means it's a nonlinear function. So let me explain why that works. I could write this equation as y equals 3 times x to the power of negative 1 minus 2. Because if we think about our exponent rules from last week, if we have a negative exponent, to change it into the positive, we put it in a denominator. And that's exactly what's going on here. We're just going backwards. So this is a nonlinear function. Alright, I'm skipping example 5, and I'm going to be actually talking about horizontal lines versus vertical lines. So, my horizontal line, if I have a horizontal line that goes through, let's say y equals 2. A horizontal line is a linear function because the x's never repeat. But if I have a vertical line that goes through x is equal to 2, for example, this one's going to be a non-linear. I apologize, not non-linear, because it is linear. It's just not a function. So we have to be careful when we see vertical lines because it's not a function, so it's going to try to trick you. Hey, is this non-linear or linear? Well, it's linear, but it's not a function because our x's repeat. Right. Please make sure that you're emailing me for help if you have any questions or talking to me in class.